once the velocity or the speed of the object reach this value, beyond that point the acceleration is equal to 0, which means that the velocity will not change in time and it will remain at the value of the terminal velocity Vt equal to the mg over b. So if we leave an object fall slowly in the medium and we wait for a while, if we measure the velocity after some time, just let the velocity reach the terminal velocity or the terminal speed, and if we measure the speed of the object, we will find that the speed is a constant. And from this fact, we can use these results to experimentally measure the constant b. That is, if we can measure the terminal velocity, we know the mass of the object, we know the gravitational acceleration, so we can calculate b from the experimental results. The velocity of the object at any instant can be calculated from the differential equation. If we write down the acceleration a, which equal to the net force over m, but from the definition this equal to the dv by dt, right? And also, as we discussed, is equal to the g minus bv over m. Okay, and this is the differential equation. We call this the differential equation. Since in the equation contain the term of the derivative, here contain the derivative in the equation, so this is a differential equation, and we can solve this using some mathematical technique. But in the introductory class, as what we are discussed here, we assume that you may not have enough mathematical skill to solve this equation directly. So I will provide you the solution of this equation. The solution. The solution of this equation is that v as a function of t is equal to the mg over b of 1 minus e to the power of minus bt over m. Okay, so this is the solution of this equation, and to verify this, it is very easy. That is, if you put this v into this equation at this position and this position, and if you can see that the left hand side and the right hand side of this equation are equal, so it means that this v is the solution of this equation. And this is very simple. You can see that if I take the derivative of v, we have that dv by dt is equal to the d by dt of mg over b of the 1 minus e to the t bt over m. Okay, which we do the derivative of the subtraction here. It means that we do the derivative of the first and the second term separately. But you can see that the first term is a constant. So it means that if you do the derivative of the first term, it will equal to 0. Right? So this will equal to the mg over b mg over b times the first term, which is 0. The second term, you calculate the derivative of e to the power of something. It will equal to the e to the power of this term also. So we have that this term e to the power of bt over m, but you have to time or to multiply this term with the derivative of the power. Okay, the derivative of the power, which here is equal to minus b over m. Okay, and finally we have that this term is equal to the g e to the bt over m, and this equal to the g minus b over m of mg over b of mg over b of 1 minus e to the power of bt over m. You can see that if I multiply this b over m to this term, this b and b will cancel, this m and m will cancel, and we have only g left, and this g multiplied by this term will cancel with this g. So we have only g multiplied to the minus of e to the power of minus of bt over m, and this minus sign will cancel with this minus sign. So at the end we have this g times e to the minus of bt over m, and this proves that this is the solution of this differential equation.